So I'm back, guys. Look at how the logical way of inserting a new element at the beginning. Look, our array before, our linked list before inserting is 14, 35, and 20. Now we want to say at the beginning we insert 75 there. So look at what is happening. Our linked list after inserting it now is 75, 14, 35, and 20. Please check carefully there. My presentation has been disturbed by the diagram. Maybe there are some errors a bit there. Look at what is happening. We are saying when we are placing a new element, a node, we are simply changing the pointer, right? We create a new pointer that is going to point to the element, and then the element that was now the head, which is 14, is now being pointed to by 75 there, right? So it actually means the location of 75 will not be 400. In fact, the location of 400 is the 14 is the memory location. 400 is the memory location of 14, and 75 should have a different memory location from 400. That was a diagrammatic error there. So it actually means that we produce a pointer that is going to point at 75, and then 75 as a memory location, we have a pointer that will point to 14, which is at 400 as the memory location. So look at what we call a header node. We have created a linked list there which is called numerals, right? So it is going to have a head, 1, 2, and so on and so forth, right? The header node exists at the front of the list, right? Even if the list is empty. So you can create a linked list that way to say you first have a header node. That is an entry point of the linked list, because we are saying elements of a linked list are thrown helter-skelter within the memory of a computer. They are not ordered in any way. So how do we define a linked list within the memory of a computer, within the RAM? We define the linked list because we will find the pointer to the first element. Then the pointer to the first element will then give us the pointer to the second element, to the third element, to the fourth. How do we know that we have access to all the elements? We will find a node whose pointer is now. If that pointer is now, it actually means it's not pointing to anywhere. We have reached the end of the linked list. So some of the linked lists that we create will not use the concept of the header, because they will start with the first element and then they go on. So some have the option to start with the header, then the header points to the first element. But we can also create it using a pointer that will point to the first element right from the word go. So look, this is what we mean by insertion after. We are saying we have 1 and we have 2. Now we have 1, 2, and 3. Look at the blue squiggly line there. We are saying our normal linked list had 1, 2, and 3. Now the squiggly line there is cancelling the pointer from 2 to 3. Instead, we establish a new pointer which comes from the value 2 pointing to the node 2.5 there. Then from 2.5 we then point to the node 3. So what are we saying? We are simply saying when we are inserting a new node into a linked list, we don't move elements. We simply change pointers, right? To say the preceding node is going to point to the new element. The new element is going to point to the succeeding node, and therefore we have created a new linked list with a new element within it. So the same happens when we are deleting, right? Look at before deletion we have 35, 48, 46 and 30. Now after deleting we have 35, 46, 30. We no longer have what? We no longer have 48. So what happens when we are deleting? To delete a node in a linked list means we change the pointers. If we have 3 consecutive nodes and we want to delete the middle one, we simply change the pointer of the first predecessor so that the first predecessor skips the middle node, and then it points to node number 3. Instead of pointing to its successor, it points to the node, to the third node after it. It actually means if we simply change pointers, we have deleted an element because it's no longer part of the list. And it is the responsibility of C++ maybe to do garbage collection or whatever. We are not going to talk about those technologies here because they are beyond your capacity. Only know that if we skip an element, if we don't point to it, it's no longer part of the linked list. And the memory it was occupying have already been returned to the operating system to say, please use this, it's no longer, it's now empty. Right? So, in that manner, you can also think about deletion. We are saying deletion simply means skipping a node, right? Insertion simply means pointing to a new value, right? So, insertion and deletion, when you are reading about it, it plays around with pointers. We don't move data items. Of course, there are principles like that when you read books to say when we are deleting or inserting, we have the option to change either the data items and then we keep the links intact, or we have the concept of changing the links and then we keep the data items intact. I would prefer you use the second one where we only play around with pointers. That is the simplest way of inserting, deleting, and even arranging. Right? So look at what is happening there. We want to delete the element 1 there. We simply cut off its pointer. Then we are saying the header node now points to 2, right? So when it points to 2, it's no longer pointing to 1. It actually means 1 has already been deleted. By simply changing the pointer, we are deleting. So look at the second element there. You look at the second diagram there. In the second diagram, we are now deleting 2. By deleting 2, we are simply jumping from 1, we point to 3. If we jump from 1 pointing to 3, it actually means that 2 has already been deleted automatically there. So deleting is simply playing around with pointers, skipping a point, we've deleted it. Then insertion, we are simply changing pointers to say the pointer that was pointing to a successor would then point to a new successor, and then the new successor would point to the point that is aftermath. So let me stop talking about the double linked list today because I'm scared my file might be too large. Hey, I'm having challenges here of file sizes. So I'll come to you maybe tomorrow morning to complete my lesson on a linked list, but I'm seeing it has been disturbed so much as I'm changing my slides and making errors there because I've changed my slides several times. My file sizes are confusing me and they are failing to get online. So please forgive me for that, but my idea is I want to complete linked list tomorrow morning. Then we talk about trees. When we talk about trees, maybe I will leave the rest of the work to Saturday when I'll be having a last lesson with you. So I will be completing data structures, then I will leave algorithms for you. It is you you who are going to do on your own searching algorithms and sorting algorithms. Those are the algorithms that I will leave with you. Otherwise, these are the algorithms like insertion and whatever. I've simplified them using diagrams here. These diagrams are representing simplified versions of algorithms. Please go and find your algorithms and even code that represents these things that I'm talking about, and practice for the purpose of making yourself ready for the examination. Thank you very much.